Welcome to the Deep Dive. I'm your host, and today we're looking at a highly technical product page from an AV retailer, um, HDTV Supply.
And I'm the resident hardware expert here, ready to dig into a very specific, very complex piece of equipment.
Yeah, the ZeeVee Z4KCXS-D ZyPer4K-XSE Decoder. And yes, I know that is a total mouthful.
It has a lot of letters and numbers.
It really is. But our mission today is to cut through all that dense audio-visual jargon. We want to show you the invisible, just heavy-duty technology powering those massive video displays you see out in the real world.
Because the engineering challenge here is actually massive.
Okay, let's unpack this. We're talking about a single device that costs almost $1,700. And it's not just some fancy HDMI cable, right? It's more like a digital teleportation device for uncompressed 4K video.
That is a great way to put it. You're moving uncompressed 4K video at 60 hertz, and you are shoving all that over a 10 gigabit network.
Which is like trying to force a fire hose volume of data through a garden hose. I mean, if you're using traditional cables.
Exactly. Traditional HDMI sends just one continuous stream down a dedicated pipe. But this decoder, it uses AV-over-IP technology.
Okay, wait, what does that actually mean mechanically?
Well, it actually chops that massive 4K feed into tiny data packets. Then it routes them through standard IT computer networks, just like the internet, and reconstructs them perfectly at the destination.
Okay, but I have to push back a little here on the specs because the page makes this huge deal out of zero-frame latency.
Oh, absolutely.
And if you chop up video into packets and send it over a network, lag is a huge risk, right? So is zero-frame latency just marketing hype? I mean, would you or I actually notice a single frame of delay?
What's fascinating here is, well, if you're just in your living room watching one screen, one frame is roughly 16 milliseconds.
Right, totally invisible.
Yeah, you wouldn't notice.
Super.
But scale that up. Think about a massive Vegas sportsbook.
Oh, wow. Yeah, where they have those huge grids of TVs.
Exactly. You have a 15 by 15 video wall, multiple screens sitting edge to edge, showing the exact same live feed.
Okay, I see where this is going.
Right. If the data packets for screen 2 arrive just a few milliseconds after screen 1, the motion doesn't match up. Your brain instantly registers this disjointed, jarring visual echo.
That would look completely broken.
It would. So zero-frame latency is the strict physical requirement to make multiple individual panels look like one single seamless window.
Okay, so the zero latency solves the synchronization problem, but once you start building out that massive 15 by 15 wall or, multi-views with up to 19 different sources, you hit a new physical problem. Distance.
Distance is the enemy of raw data, yeah.
Because the source says this decoder pushes signals 100 meters over a standard Cat6a cable. How does it pull that off when a normal HDMI cable taps out after, 10 feet?
It comes back to that AV-over-IP network architecture again. Cat6e is a high-bandwidth Ethernet cable designed for heavy data traffic in IT data centers.
Oh, so it's writing the IT infrastructure.
Exactly. Because the video is packetized, it can ride that 10 gigabit infrastructure for the length of a football field without any signal degradation.
Here's where it gets really interesting, though. Because sending raw data over an IT network sounds incredibly vulnerable. It's like sending a high-speed, heavily armored convoy spanning the length of a football field.
That's a really good analogy.
And the source highlights AES 128 and HTTP 2.3 encryption. Mechanically, what is that actually doing?
Well, it's far more than just a locked door. Take HTTP 2.3, for instance. It isn't just an acronym. It's a constant mathematical digital handshake.
Wait, constant? Like every second?
Every single second. When a commercial venue is beaming licensed, premium content, like a live sports broadcast, Hollywood studios and sports leagues require absolute protection against piracy.
So if the screen fails that digital handshake,
the feed immediately goes black. It acts as the ultimate verification checkpoint at the end of that 100-meter cable.
That is wild. It's ensuring that complex handshake happens instantly across potentially hundreds of screens, all while reassembling 4K video packets with zero delay.
That's the core of the engineering right there.
It really puts commercial AV into perspective, and what's interesting is the source notes this specific unit is a revision 1 device. It's actually already been replaced by newer models.
Technology moves fast.
It does, but looking at its specs gives us a clear window into the invisible infrastructure required to beam flawless video across huge spaces. So the next time you are sitting at a sports bar looking at a seamless wall of TVs, you will know exactly what kind of heavy lifting is happening right behind the drywall.
Which brings up a really provocative question, I think.
Let's hear it.
If a heavy-duty wired device can push uncompressed 4K over 100 meters with absolute zero lag today, What happens to this entire hardware industry when wireless transmission finally cracks that zero latency physics problem?